Hi everyone, welcome to my SeeStar video series in which I will go over processing data from the SeeStars on a computer. So the first video in this series, which is the one you're watching right now, is how to process SeeStar data using only free programs, in which I'll be using SIRIL GraXpert and StarNet2 to process SeeStar images. Video 2 is going to be about processing SeeStar data from beginning to end in PixInsight using only free plugins, which includes GraXpert and StarNet2. And video 3 will be about processing SeeStar data using paid RC Astro plugins, which I use, such as Blur Exterminator, Noise Exterminator, and Star Exterminator. And I'll be going over everything from A to Z, including finding and installing the programs and then processing everything. So let's get started for video 1. The first thing you would have to do is transfer the data from your SeeStar to the computer, of course. Once you've done that, you will need to download and install SIRIL if you don't already have that. The current latest version, which I have a link to in the description of this video, is SIRIL 1.2.6. So you can go to that link in the description of this video and download that. Second, you'll need to download GraXpert 3.1.0 RC2. Now, this is a beta version of GraXpert. This is not the one you'll find if you are just using Google to find it. I have a link to this in the description of this video as well. So this is what the page will look like when you click on that link. And you'll have to go to the bottom of that page and download the version for your operating system. In my case, it's GraXpert-Windows. And once you've downloaded and installed that, you'll need to download and install StarNet2, the command line version. And this is where that link will take you. So StarNet, just scroll down here until you see the command line tool heading. And over there, you'll need to download it for your operating system. And for me, it is fresh install StarNet2 for Windows. Once you've downloaded and installed that, you will need to open up SIRIL and download the SIRIL SeeStar script. Once you are on this page, which I will also have a link to in the description of this video, on the very right-hand side, click on this downward facing download arrow. And figure out where you want to save your SeeStar scripts. So I'll create a folder called SIRIL Scripts, and just remember where that is, that folder here. And in the SIRIL Scripts folder, save the SeeStar pre-processing script. Now that that is done, let's go to SIRIL and we will add the location of StarNet2, which we previously installed, and the SIRIL scripts. Now open up SIRIL. Go to where you see these 3 bars at the top. Now you can also make SIRIL not full screen here, so you can actually see other things around it as well. So go over here where you see these 3 bars, click on that, click on Preferences, and go to Scripts. And over here, we're going to put the location where we saved that scripts folder. So there it is. That is the SIRIL Scripts folder that I created. Open that. Note down the location of that folder. In Windows, you can just click on the bar up here and just copy that address to this folder where the SeeStar script is saved. Go back to SIRIL and just paste that in here and then click Apply. Now we also need to go back here, go to Preferences again, and under Miscellaneous at the bottom, put in the location of the StarNet software that we installed, the command line StarNet software. So click on this folder. And in my case, I had put it under downloads, or it was still in downloads, StarNet2 CLI, which means command line interface. And inside that folder, I have StarNet++.x. Click on that, click open, and that's done. Click on Apply. And now we just need to restart SIRIL. So close that, restart it again. And while that's restarting, let's check here. So we have done all of that, and you only need to do that one time, just the first time if you don't have these programs installed. Once you've done that, you are good to go. Now, our next step is to set the home folder in SIRIL and then stack the data. So this was all of the data, M42 underscore sub. This is all the data that I'd copied over from the SeeStar, all of the individual fit files. So what I'm going to do is I created a new folder called SIRIL Processing M42 because that's the target. Just note the location of this folder, where it is, and inside I created another folder called lights. I copied and pasted all the fit files of M42 from my SeeStar into this lights folder. So those are all saved in here now. Now I'll go back into SIRIL and click on this home button up here. And then I will navigate to where I saved that folder. So this is the SIRIL Processing M42 folder that I created for all of my files related to M42. And inside that is the lights folder. Now I don't want to click on the lights folder. I just want to be in this parent folder called SIRIL Processing. And just click OK or open. And now if you look up here, it says SIRIL Processing M42. So that is now the master folder where everything is going to happen. And all I need to do now is click on scripts, SeeStar Processing. That's the only script I have over there. And when I click on that, SIRIL will automatically start processing all of the lights that are in this SIRIL Processing M42 folder. And once that's done, we can proceed to actually doing the processing. So if you look at my process over here, that is done now. And actually that'll be done. It's very fast. It doesn't take very long. And we can follow the progress here in SIRIL and we can see what it's doing. Okay, done. It says total execution time 26 seconds. Okay, now that SIRIL has finished stacking the image in our SIRIL processing folder, we see that there is a new processing folder and the stacked image. And as you can see for this image, SIRIL stacked 244 images of 30 seconds each. Now, if we look at my process over here, once SIRIL has finished stacking the data, we will first open it up in GraXpert, and then we will crop the image, do background extraction. We will do deconvolution and sharpening, both the stars and the object, and then we will do denoise and then finally save the image. Now we will have to save the image between each of these steps in this version of GraXpert. So let's get started. Open up GraXpert. Now if this is your first time using GraXpert, you will have to go to the right of the screen here where it says advanced and click on that, and then scroll down. And then for background extraction, object deconvolution, star deconvolution, and all of these, click on this downward facing arrow and select the newest version of each. So in this case, the newest version is 1.01 for that, 1.01 for that, 1 for that. So just go down and just select the latest version of each of these for all these, including denoise model. And once you've done that once, you don't have to do it again. And then SIRIL will download any other data that it needs after you've adjusted those settings. Now, first thing we're going to do here is crop this image. So click on the plus sign next to crop and grab these little circles in the corner and frame the image nicely. What this will allow us to do is to get rid of any bad corners that the image had because of imperfect stacking or because of field rotation or anything like that. And it'll also just frame the object better. So I think this looks pretty good to me. Once you've framed it the way you like it, click on apply crop. And once you've done the cropping, go down to the bottom here where it says save and save the image. And then we will load it again to do the next steps. So click on save and leave the format as the default 32-bit TIFF. Then click save selected. And we'll just save it in this folder. Just leave it as whatever name GraXpert gives it. In this case, it just says a GraXpert at the end. That's fine. Click save. Now go back to loading and load that image that we just saved, the one that says GraXpert at the end. And it has loaded that. Now we'll go to the next step, which is background extraction. And just click calculate background. So that has removed any of the gradients in the image, and it did a pretty good job. Save that new image now. If you don't save in between, it'll undo any of the changes you did in the previous step. So we just have to save. So save selected, just save that one here. Now you can see it has added BGE, background extraction, to the end of this name. Now we'll go back, load that latest saved image that we did background extraction on, and go to the next step, which is deconvolution. And over here, select object only. For object only, you can increase the deconvolution strength to something like 0.8 and leave that as default. Click deconvolve image. And as you can see, the image got a lot sharper, the object itself, not the stars. If you want to do a before and after comparison, you can go up here where you see the downward facing arrow and click on original, and that's what it looked like. Keep an eye on this part of the image here, this darker region, when I switch over to the deconvolved only image, and you can see it got a lot sharper. If it's too sharp, you can undo that by going back here to the original and then apply a lower deconvolution strength, but I think 0.8 in this case was pretty good. So this is the one. Now save this again. Save selected, and it'll save it there. It says object underscore decon as the new name. Now load that latest object underscore decon image and go back to deconvolution, and now select stars only. And for deconvolving stars, I'll set it to 0.4. Deconvolve image. There we go. As you can see, the stars over here at the bottom got a lot sharper. If we look at before and after, this was the before. As you can see, the stars are pretty streaked, and this is after. So the star, it is a big improvement. Save that image. Save selected. Just let it name it itself. It says underscore decon at the end. Now load that latest image. Click open and go to the next tab, which is denoising, and you can denoise at maximum strength. That is fine. And this might take about 30 seconds or a minute or so. And as you can see, it has done a great job denoising the image. If we look at the original and the new one, this is much smoother. And don't worry if the background looks a little bit too smooth right now. That's not an issue. And just save that latest image, and again 32-bit TIFF, save selected, and just save it as whatever name it gave it. And that's it, that's done. Now we can close that. Now here is the folder where all of these are saved in, and the only one that we actually need is the latest one. You can delete all of these other TIFF images. I would leave the original fit image that SIRIL had stacked. Just delete these newer 4 images and leave the most recent one that we saved that has all of these changes applied. But since the name is really long, I'll just rename it something like M42 underscore GraXpert. There we go. Okay. Now, if we look at my procedure, we have done all of these things in GraXpert. We've done the background extraction, deconvolution, and denoising, and we have saved it as a TIFF image. So let's open up SIRIL. Okay, in SIRIL, we can either drag and drop the image or click on open up here, and there is the image. So find where that is and click open. And as you can see, the image looks pretty dark right now. Now, if you have SIRIL maximized using this button at the top here, the center square, you might not be able to access anything else down there. So you can just click this button and then adjust the size of the SIRIL window on your screen. Now, so we have the linear image here and it looks very dark. That's perfectly normal. Go down here where it says linear, click on that, click on high definition, and go to linear again and click on auto stretch. Now this shows us all the data that is actually in the image, but it hasn't applied any other processing yet in SIRIL. Okay, so the next step for us to do is to plate solve the image and do color calibration. And we're going to do both of those steps using the photometric color calibration process. So go to image processing, color calibration, and photometric color calibration. Now up here we're going to do the plate solving, so click on this empty area over here and type in the name of the object that you imaged or that general region. So M42 is the Orion Nebula. Click find. There it is, it found it. And click OK to do the color calibration. There it is. So the color calibration is done. Click close. Now next step for us to do is star removal, and we'll be doing that by using the StarNet star removal process. So that's under image processing, StarNet star removal. Okay, go to image processing, star processing, and StarNet star removal, and select pre-stretch linear image and generate star mask. Click execute. And as you can see, the stars have been removed from the image, which is exactly what we want. Now, if we go to the folder where we had saved everything, the SIRIL processing folder, it has created two images now. There is a Starless M42 image and there's a star mask, which is the stars only image. So we are going to open the Starless image. That's already open over here, but we can always just drag and drop the Starless image in here. Click open. And we're going to process this Starless image using generalized hyperbolic stretch. And then the stars we're going to stretch using histogram transformation. But let's stretch the Starless image first using generalized hyperbolic stretch. Go to image processing, generalized hyperbolic stretch transformations, and this is what it looks like. So first thing we're going to do is find an empty part of the image that doesn't have a lot of nebulosity or stars or anything like that. Down here looks pretty good. It's okay if there's a tiny bit of nebulosity, and just make a little rectangle here with your mouse by clicking and dragging. Once you've done that, on this screen, hit this dropper tool button, and that will automatically set a symmetry point. Now over here we want to zoom in a little bit. Up here it shows 1x zoom right now. Zoom in to, let's say, 100 times and click enter. Now once we zoom in here to, let's say, 100 times, we can see that this histogram is very close to the left hand side, which is good. Let's say this histogram was over here near the middle. We would switch this generalized hyperbolic transform to linear stretch first, and we would click on this plus button over here until it was very close to the left hand side. And once we had done that, we would click apply. But in this case, we don't need to do that step because the histogram is already very close to the left hand side. So we can skip that step, and we will go straight to the generalized hyperbolic stretch transform. So the first thing we're going to do is use our mouse and draw a little rectangle in an empty part of the image that doesn't have a lot of nebulosity or stars or anything like that. Someplace that's fairly smooth. So we don't want it to be, let's say, over here or over here, just a little empty area. We'll come back to this screen and hit this little dropper tool, and that will automatically set the symmetry point for us. And next, drag this local stretch intensity value, which is B, all the way to the right side to 15. And once we've done that, go down here to the bottom where it says auto stretch and set this back to linear. And now we can start stretching the image using this stretch factor slider. Now stretch it until it's fairly visible. You don't need it to be very bright at this point, like this. Just fairly visible or faintly visible is good enough. And once you like that, click apply, then click reset. And now we will start doing this again. So again, click on this dropper tool, set this local stretch intensity value to maximum, and then start stretching again. So now you can stretch until you are happy with the background level here, with the brightness of the nebula. And as you can see, by stretching using this method, you can still see some detail in the middle as well as in the nebula. And now you can adjust the symmetry point a little bit by using this plus button here, or by just dragging this symmetry point slider, and there we go. But you can do it more accurately just by, let's say it's a 0.167, you could do 0.2. So you can adjust it to adjust the contrast on the screen here. I think that looks pretty good here to me. Click apply and click close. Okay, we can click anywhere on the screen, left click to get rid of that little box that we had used. Now we want to adjust the contrast of this a little bit more, so we can go up to image processing, histogram transformation, and just click the reset button here. Okay, and oh yeah, the magnification is too high. It's set to 100 times. Click on this 1x to reset this. Now we want to drag this slider from the left a little bit over to the right to darken the background. And if you want to brighten the image overall, you can do that by dragging this slider to the right, but then that'll make the center too bright. So we don't want to do that. Let's just reset this and do this again. Okay, so drag this a little bit over, darken the background a bit, click apply, click reset, and you can do this again. Okay, I think that looks pretty good. If we want to zoom in, we can zoom in using this slider up here, or this plus button, and then we can make any fine adjustments that we want. But we don't want to clip the histogram too much like this. I think it's best to leave it like this. So I think that looks pretty good. So I will hit this 1 up here to reset the zoom, click apply, and click close. One other thing we should actually do while we're at it, while we're on the Starless image, is to adjust the color. Click on image processing and color saturation. Now we can adjust the amount of saturation we want in the nebula. Okay, I think that looks pretty good. And this background factor, we can lower this as well, because if we increase the background factor, you'll see that it'll try to do some denoising, and it won't apply the saturation very strongly. So we can decrease this a bit. The colors look pretty good. Click apply. Okay, and now we will save our Starless image that we created by going up here to this downward facing arrow at the top right. Click the downward facing arrow, and for the file format, you just want to leave it as a .fit. So we will call it M42_Starless. Save that. And yes, default settings over here. And then we will open up our stars only image, which is this one here, StarMask_M42. And as you can see, this looks pretty dark, but that's the stars only image. And we'll go up to image processing, and we'll stretch it using histogram transformation. And that's what it says over here as well. For the stars data, we stretch it using histogram transformation. Now to do that, all we need to do is just grab this middle arrow over here and drag it towards the left. Click apply, click reset, and then do it again. We can do it in little increments, as that gives us more control. We don't want to overstretch it like this where the stars are too bright, and we don't want them to be too dark. So just so they look pretty decent. So something like this is pretty good for the Orion Nebula. Click apply, reset, and click close. And now we are going to save this stars only image. So again, go up here, click on this downward facing arrow, file type here, leave it as the first one, fits, and we will name this one M42_stars, because this is stars only. Save and save. Now our next step here is to combine the stars and the Starless image using processing, star processing, and star recombination. So go up to image processing, star recombination. For the first option over here, select the M42_Starless. For the second one here, select M42_stars. And there we are. As you can see, both of these have been combined. Now over here, we can stretch the nebula and the stars a little bit more or a little bit differently again if we want. Set the stretch intensity here to maximum. And then you can use this stretch factor slider up here to stretch it a little bit more until you're happy with the brightness of the image. Or you could also use this plus button here to make very, very slight changes. And for the stars, you can stretch them a little bit more here as well if you want, just using the stretch factor slider, but I don't think we need to do that. The stars are fine as they are. Click apply, click apply here, and then close, and then that's our final image. Now if there is any sort of a green cast still left, we could use the remove green cast option here in step 11. So that would be image processing, remove green noise, and just click apply. And if there is any green noise, it'll remove that. But if we go before and after, there really isn't anything here to worry about. So that step is optional. And then last step, if we need to adjust the color saturation, we could do that again still. That's going up to here and adjust that if needed. But I think at this point we are good. And then lastly, save your image. So go back here, click on this downward facing arrow again. And for the final one, we can save it once as a TIFF because that's quite compatible. So we can save it we can name it something like M42_final. And for the final save, we could do it as a 16-bit unsigned integer, so it doesn't take up too much space, and then save it again as a JPEG. That JPEG you can share with your family and friends. And for the JPEG again, just name it M42_final.jpg. Okay, save. And for JPEGs, I always save them at maximum quality. Hit save. And we're done. Now we can close SIRIL. And if we want, we can delete any of those intermediate step images, or we can leave them there, but the only one we need is the final image here. If we want to make any other adjustments, for example, in Photoshop or GIMP or something, this is the one you'll use, M42_final.tiff. If you just want to share your image and you're happy with how it is, M42_final.jpg. There it is. That's the image we took with a SeeStar S30, and I think that's a beautiful image of the Orion Nebula. I know there were a couple of steps involved here, but I think that looks like a very nice image, so I would be very happy with that. And if you used this tutorial to process your own image, make sure you share it online and tag @AbdurAstro, just so I see it as well. I love to see the images that people have taken or processed using some of my instructions online. So I hope you found that tutorial helpful. If you have any questions at all, leave them in the comment section of this video and I'll be sure to reply. So thanks again for watching, and clear skies.